Hello and welcome to another video brought to you by RouTube. This video will focus on simplifying algebraic expressions through the use of the four operations. Students are introduced to many of these concepts in this video in Year 8 and then continue to develop their knowledge in Year 9 and beyond. Okay, so the learning objectives for this video, there are three of them. The first one is to identify like terms. The second one is to be able to simplify algebraic expressions by adding and subtracting like terms. And the third and final objective for this video is to simplify algebraic expressions that involve multiplication and division of multiple algebraic terms. All right, let's start by identifying like terms, because if you can't identify like terms to begin with, then simplifying through addition and subtraction becomes virtually impossible to do. Okay, so like terms, what are they? So like terms are terms that have identical pronumerals. Okay, we know what pronumerals are. They are just letters or variables. So they must have identical pronumerals and identical powers. Okay, now you'll see and is written in bold. Okay, and it's really important because like terms must have both identical pronumerals and identical powers. Okay, not one or the other. They must have both to be like. Now, like terms can and often will have different coefficients, which we'll see as we proceed through as well. So let's have a look at the left-hand side box. These are examples of like terms. So the red one, we've got 4x and 5x. We have identical pronumerals, both terms having x, and both of the pronumerals x are raised to the power of 1. Okay, we know in algebra, if there's no power, it's just a power of 1 hiding there, which we do not write. So that's an example of like terms. Next, we have negative 8c squared d and 3c squared d. So we've now got different coefficients, which is okay. Even though one's a positive and a negative, that's still okay. We've got the identical variables, so the same variables in both terms, both c and d, and the c in both terms is raised to the power of 2, and the d in both terms is raised to the power of 1. So that is once again an example of like terms, which means they can be added and subtracted together. And then the third one, the green one, we have 14e cubed x squared and negative 5x squared e cubed. Now this is a little bit of a trick, and you'll probably see this more so in a test setting where normally we see the pronumerals written in alphabetical order, but sometimes they switch that order and they reverse it to try and trick you. Okay, but it's really important we go with the same idea that I've got highlighted there. If it has identical, the same pronumerals and the same powers, then they are like terms. So here we've got 14 and negative 5, different coefficients, which we know is fine. And then we've got e to the power of 3 in both terms. And then we've got x squared in both terms. Okay, so just because they're written in a different order doesn't mean anything. As long as I've got the same variables and the variables are raised to the same power, they are like terms. Now moving our attention to the right side, examples of two terms that are not like. Okay, so negative 11p and 11p squared. So they've both got p's as the variables, but the p in the first term is raised to the power of 1 and the p in the second term is raised to the power of 2. So that means they are not like terms. The orange one, we've got 4x squared and x cubed. Okay, so with both terms, we have the variable x clearly, but the powers are not the same. One is, the first term, the power is 2. And the second term, the power is 3, so therefore they are not like terms, which means they cannot be added or subtracted together. And the final one, the pink one, is negative 6m cubed n squared and 9n cubed m squared. So just like the green one we saw before, now they are reversing the order. So the coefficients can be different, that's okay, but the m in the first term is raised to the power of 3, and the m in the second term is raised to the power of 2. So they've swapped the 3 and the 2 with the m and the n. So the n in the first term is raised to the power of 2, and then the n in the second term is raised to the power of 3, which therefore means that they are not like terms, so they cannot be added or subtracted together. Now we can simplify like terms by adding or subtracting the coefficients to form a single term. We cannot simplify any terms that are not like terms through addition or subtraction. Just going to highlight that very last sentence, okay, because that's a really important thing to note and often where mistakes get made. So we cannot simplify any terms that are not like terms through addition or subtraction. Multiplication and division are totally separate, and we'll get to that later in the video. But when we are adding and subtracting, we can only add and subtract terms that are like. All right, let's have a go at simplifying algebraic expressions by addition and subtraction. So simplify the following expressions. So the first one, we've got y plus 2y plus 3. Okay, now it's really important, as we said previously, you can only add or subtract terms that are like. So in this first algebraic expression, we hopefully can identify we have 3 terms in this algebraic expression. We've got y, we've got positive 2y, and we've got positive 3. Remember, each term gets separated by the operational sign. So, as I said before, we can only add or subtract like terms. So, hopefully we can see that the first 2 terms, which I've underlined in green, are like terms because they have the same variable and the variable are raised to the same power, which in this case is 1. Now what I'll do, that third term that I've underlined in purple, that is not a like term with the first 2 terms, okay? That 3 is what we call a constant because it is a number in an expression that does not have a variable attached. So it cannot be added or subtracted and joined to the rest of the other terms. So what we do now is we simplify, we collect like terms, which are the green ones. So here we've got y plus 2y. So essentially out the front of the y is a 1. So now when we add or subtract and collect like terms, we don't change the power. Okay, so the power is going to stay the same, the variable is going to stay the same. The only thing that's going to change is the coefficient or the number of y's that we have. Okay, so essentially we just do 1 plus 2, which is 3. So we've simplified the first 2 terms to give us 3y. And then because we can't join the positive 3 together because it's not like, it's a constant, we then just add the positive 3 to the end of our 3y. So we have 3y plus 3. And there's our finished answer. Now the reason why we can't join to make it 6y is because, like we said, we can only add or subtract like terms, and 3y and positive 3 are not like terms because the second term does not have a y, so therefore it's not like. Moving on to the second question, question B. So 4a squared b plus 7ab squared plus 3ba squared. So now this one can get a little bit tricky because there's a's and b's everywhere and squareds everywhere. Okay, but go with the same idea that we spoke about previously, same variables, and the variables have to be raised to the same power. Hopefully you can identify the first term, which is 4a squared b, and the third term, which is 3ba squared, are like, which then leaves that middle term as not being a like term. And the reason why the green ones are like terms is because the a are both raised to the power of 2, but in the middle term, that purple term, the a is not raised to the power of 2, the b is. Okay, so that's why the purple one, the middle one, 7ab squared, is not like. So now we join or collect the 2 like terms, we join those together, so it becomes 4a squared b plus 3, and now it doesn't matter which order you write it in, I'm just going to write it in alphabetical order, a squared b. Now remember, we're not changing any of the powers, so it's still going to be a squared b. The only thing we're going to change is the coefficient. So we're just going to add 4 plus 3 to give us 7. And then just like we did before, we can't join the purple term, the second term, the one we underlined in purple, so we just add that to our answer. So we've now got 7a squared b plus 7ab squared. Bit of a tongue twister, but we can't add them together because they are not like terms. So there's our finished product. And then now finishing off with question C. So now we've got negative 8 minus x squared plus 9 plus 3x squared. Now this one's a little bit different because hopefully you can identify we've got 2 sets of like terms. So we've got 4 terms in this algebraic expression, and we have 2 constants and 2 terms that contain x squared. Okay, so the first set of like terms are -8 and +9. And then the second set of like terms are -x squared and +3x squared. Okay, so same idea. We go with the same variable and the variable raised to the same power, even though the coefficients are different, which is okay. So now let's join the greens together. So now we've got -8 plus 9. Now, if you've got a calculator in front of you, please utilize it, especially if you find dealing with with negative numbers a little bit confusing. That's okay. So -8 plus 9 should be +1. And then we've now got -x squared plus 3x squared. Once again, we're not going to change the power. We're just going to change the number of x squareds that we have. So -x squared just means that we have -1x squared. So therefore, we're just going to add the coefficients. So -1 plus 3 should hopefully give us +2x squared. And then now we can bring both of our answers together. Now, generally, I'll write it as we see it. So we've got +1 plus 2x squared, which is totally fine. But generally, we write the constant last. Okay, so we generally write it as +2x squared plus 1. Okay, so how I would write it would be that bottom one there. So we always have the constant last, and we don't need that +2 out the front. So we just leave it as 2x squared plus 1. All right, let's move on now to multiplying algebraic terms. Now, everything we've learned about like terms sort of goes out the window when we're talking about multiplying and dividing. Okay, and the reason why that is because we can only add or subtract like terms, but we can multiply any terms together. Okay, so let's have a bit of a read. So like I just said, any number of algebraic terms can be multiplied together to produce a single term. So now we don't need them to be like anymore, only when we add or subtract. When multiplying terms, multiply the coefficients first, then multiply the pronumerals in alphabetical order. So there's a bit of a step-by-step process there. Always start with the coefficients and then deal with the pronumerals afterwards. And then when multiplying pronumerals, add the indices together, which hopefully you have an understanding of the index laws, which sort of goes back to the first index law, where we have the same base, we're multiplying, so we add the indices together. All right, let's have a go at simplifying algebraic expressions by multiplication. Now, as you'll see, let's simplify these expressions. Now, as you'll see in A and B, we've got plenty of stuff going on, but we don't need to identify like terms anymore because, like I said and have said previously, we don't need to identify like terms with multiplication and division, only for addition and subtraction. So in this expression, we have 3 terms. We've got 3x times 4y multiplied by b. Now, if you would like, hopefully you know that it's there already. Before the b, there is a 1 hiding there. Okay, please make sure that you know that the coefficient of b is 1, as I've just drawn. So, as we saw in the previous part of the video, what we need to do when we're simplifying algebraic expressions with multiplication, we always start with the coefficients first. Okay, so we've got the coefficient of 3, 4, and 1. Now, if you don't know that the 1's there, that's okay, because multiplying by 1 does nothing to your number anyway. Okay, so let's start by multiplying the coefficients together. So we've got 3 times 4, and I'm just going to multiply the 1 on the end, even though it doesn't matter, even if you just do 3 times 4. So 3 times 4 is 12, and then 12 times 1 will give you 12. Okay, so our coefficient of our answer should be 12. Now let's multiply the variables together in alphabetical order. So now the first one should be b, and the next one, which will underline b, times x times y. Times y. Hopefully we know, we just rewrite that as bxy. So we join them together, remove the multiplication signs, and write them in alphabetical order as we have done. And then what we do, we just bring them together and we join the coefficient with the variables. So we've got 12b, x, y. And there's our finished product. Moving on to part B. So we've got 7cx multiplied by -2cd multiply by negative 3c squared x. All right, so plenty of stuff going on. Once again, we don't need to worry about like terms because we are multiplying. So same process as before, multiply the coefficients. Now you might need a calculator for this, especially seeing as we have negatives going on here. Okay, so let's follow the first process. So we've got negative, oh sorry, that should be positive 7, not negative 7. So we've got 7, multiply by negative 2, multiply by negative 3. Now once again, if you've got a calculator, don't be afraid to use it. So we've got 7 times negative 2. Well, a positive times a negative should give you a negative. It should be negative 14. And the negative 14 times negative 3. Negative times a negative will give you a positive. And 14 times 3 should hopefully be 42. And then we can now multiply all of our pronumerals in alphabetical order. So the first one we have is we've got C. Then the second one we've got is another C. Then the next one we've got is a C squared. Then the next one we've got is a D. And the next one we've got is an X. And then the next one we have is another X. All right, so let's join them all together. So C times C is C squared. Remember the first index law, multiplying, same base, add the indices, and then multiply by C to the power of 2 should give us C to the power of 4. And then we've just got the D, and then we've got X times X should be X squared. So then now, once again, we have our coefficient, which is 42, and then we rewrite our variables in alphabetical order with the correct powers. So 42, C to the power of 4, D, X to the power of 2, or X squared. And there's our finished product. All right, now let's have a go at dividing algebraic terms. So when dividing two algebraic terms, the first step should be to rewrite the terms in fraction form. Now, sometimes you'll be given it already in fraction form, but sometimes you'll be given the two terms with a division sign. So if you already have it in fraction form, then obviously you don't need to rewrite it in fraction form. You can just progress to step 2. So then once rewritten as a fraction, simplify the fraction by finding the highest common factor, the HCF, of the coefficients and then cancel down the pronumerals. And then when dividing pronumerals step 3, we follow another index law. In this case, we follow index law 2, which says that we need to subtract the indices. All right, let's have a go at simplifying algebraic expressions by division. So simplifying the following expressions. So the first one we have already in fraction form, which is fantastic. So we have 16ab divided by 4b. Okay, so that vinculum, that line in a fraction, which is called the vinculum, that just means division. Okay, so we could rewrite it as 16ab divided by, with a division sign, 4b, and it would be the exact same thing. So I'm just going to rewrite it here, just so we have it a little bit bigger. So 16ab over 4b. Okay, so once again, what we need to do, we need to cancel by finding the highest common factor between the coefficients first. Okay, so your job is to identify what is the highest common factor between 4 and 16. And hopefully you have identified that that is 4. So 4 goes into 4 one time and 4 goes into 16 4 times. Okay, so let's rewrite what we have. We now have 4ab over 1b. Now we know we don't need to write the 1, so let's just remove it. Now we can't simplify anymore because we just have one coefficient left. But what we can do is we can cancel some of the pronumerals. So we now have AB on the top and we have B on the bottom. So what we have is we have a B on the top and a B on the bottom. Remember, what you do to the top in a fraction, you must do to the bottom. So we can actually just cancel out these B's here. Because we have cancelled one from the top and one from the bottom, the fraction is still happy. So if we cancel that out, we're just left with now 4a. So we're no longer left with a fraction because we have cancelled and simplified the coefficient by finding the highest common factor and then cancel the b's out, one from the top and one from the bottom. So the final answer should be 4a. Moving on to the next one, we've got 3x squared y cubed divided by 18xy squared. All right, so like I said before, we need to rewrite it as a fraction. So let's do so. We've got 3x squared y cubed over 18xy squared. Now what I'm actually going to do, I'm going to rewrite it. I'm going to stretch out the variables. So what we're going to do, I'm going to rewrite 3 times, and instead of writing x squared, I'm going to write it as x times x. And then instead of writing y cubed, I'm going to write it as y times y times y. This will help with the cancelling process of the variables, which we'll go through in a second. And then this is going to be 18 multiplied by x multiplied by y times y. Okay, so now let's do what we did before and simplify by finding the highest common factor. So highest common factor between 3 and 18. Hopefully you can see that that should be 3. So 3 goes into 3 once, 3 goes into 18 6 times. Okay, so let's rewrite what we have. We've now got 1 times x times x times y times y times y. Okay, now it's important to note you don't have to set it out like this. This is just going to help us when we get to our simplifying of our variables. So on the bottom we should have 6 times x times y times y. Now when we have a coefficient of 1, which we have now, that means that you are finished simplifying. Okay, so now what we have is, like we did with the b's in the previous question, we can cancel some of the variables from the top and some of the variables from the bottom. So we had 2 x's on the top, but only 1 on the bottom. So that means we can cancel 1 from the top and 1 from the bottom. But we can't cancel this one here that I'm going to circle in green, okay? Because we don't have another x to cancel on the bottom. So we're going to leave that one there. And then now with the y's, we've got 3 on the top and 2 on the bottom. So we can cancel out 1 and 1, and then 1 and 1. But just like the x, we need to leave a y on the top, because we can't cancel that one because we don't have a third y on the bottom. So then now once we've cancelled all that stuff, let's actually work out what we have. So at the top we've got 1 x, and y, and on the bottom we've just got 6. Now to rewrite it correctly, well, that is correct, but we know we don't write the 1 as a coefficient. You can, but we don't need to. So the correct answer should be xy over 6. Thanks again for watching another video brought to you by RouTube. Feel free to like and subscribe to my channel, and I'll catch you next video.